Hi class, welcome to our notes 1.3, Comparing and Ordering Rational Numbers. If you have arrived at this video, I take it that you've already finished the 1.2 notes and you have also already finished the IXL practice for finding the absolute value of numbers. If that's the case, let's jump right into the next part. So for starters, I want you to remember that rational numbers can be represented as fractions. Rational numbers can also include decimals, integers, and integers are positive and negative whole numbers. Okay? That's supposed to be a C. All right. Also, I want you to remember that although all number lines do not have notches in between the whole numbers, it is understood that in between each of the whole numbers of a number line are decimals. So for example, this first notch right here represents 0.1, then 0.2, 0.3, 0.4, 0.5, which is half, 0.6, 0.7, 0.8, 0.9, and then the whole number 1. Now, although, like I said, all number lines, such as the one that we looked at in our first set of notes, not all number lines have those notches in between. But if we are aware of how the placement of these decimals fall on a number line, then it will help us with this unit when we get to comparing and ordering rational numbers. With that being said, I want you to draw a little line, a little squiggle, right on the side of this, and I want you to write a very, very important note. Okay? When comparing rational numbers, turn any fractions into decimals. Okay? When you're comparing rational numbers, I want you to turn any fractions into decimals. The reason why I want you to do that is so that when it comes to lining up and figuring out which particular number is greater or less than the other, you need to have that in decimal format because it'll make it a lot easier for you to be able to see that. Moving right along, I want you to remember what these mathematical symbols here mean. Remember that this symbol means less than, this symbol means greater than, and this final symbol means equal to. Now, when we're talking about a word called inequality, then we're referring to situations where numbers are not equal and they're either less than or greater than one another. But when we're talking about situations of equality, we're talking about numbers that even though they may look a little differently, they are exactly equal. Now, we're going to go ahead and jump into some practice problems. I'm going to start and do 2 of them, and then I'm going to let you complete the rest. The first practice problem, I want you to fill in the blank with the less than, greater than, or equal to sign in order to make each sentence true. So remember what my note said. When you see any fractions, you need to make sure that you turn them into decimals because that will make comparing and ordering 10 times easier. So in order to do that, we're going to start with this first fraction. We're actually going to come over to the side and we're going to divide that because we learned in our last little unit that the best way to turn a fraction to a decimal is through division. So I'm going to write 2 divided by 3. I recognize that 3 cannot go into 2, so I'm going to put my decimal place. I'm going to add in a 0. 3 can go into 20 6 times, because 6 times 3 is 18. And when I subtract that, it's going to leave me with a remainder of 2. I'm going to bring down a 0. 3 goes into 20 6 times. It's 18. So I see a pattern here. Okay? I don't need to keep going because I know that this number is going to continue to repeat. So what I can make this number be is 0.6 with a bar on top. That bar means that this number 6 is going to continue repeating. Okay, so it's going to keep going and be 6, 6, 6, 6, 6, or whatever. Alright, so now that I'm done with that, I'm going to go ahead and change my second fraction into a decimal. So, same thing. I'm going to say 5 divided by 8. I know that 8 cannot go into 5. So I'm going to put my decimals and add in a 0. 8 can go into 56 times. 8 times 6 is 48. And I subtract those two. I end up with 2. Bring down my remainder. 8 can go into 20 2 times. That's going to give me 16 with a remainder of 4. And finally, 8 can go into 40 5 times, which leaves me with no remainder. So, 5 over 8 is the same thing as a fraction, 0.625. Okay? Now, if I know that this is 0.666666, going on and on to infinity, and I know that this is 0.625, then I understand that 2 over 3 is greater than 5 over 8. Okay? So that's my first problem. Now let's look at number 2. We have 2 decimals, but it's very important to pay attention to place value. I have 0.03 and then I have 0.0003. Alright? So if I look at this place value, I know that my 3 falls in my hundredths place. And if I look over here, then I know that in the hundredth place for this decimal, there's a 0. So what that tells me is that this number is greater than this number. So I'm going to fill in my sign accordingly. Now I want you to go ahead and pause the video now, come back when you have finished the problems, and we'll check over them to ensure you have the right answers. Alright, I take it that you have finished the problems. Now we can go through the answers. Okay? In the case of 1.1 and 1.05, 1.1 is greater than 1.05. Okay? When we have 3 over 4 and 0.5, if I know decimals and I know that I'm dealing with fourths, then I can think about quarters. So 3 over 5 is the same thing as 0.75. Okay? And that means that 3 over 4 is greater than 0.5. Okay? Because 0.75 is greater than 0.5. Alright? Now, we have the absolute value. So I'm going to go ahead first take my absolute value. The absolute value of negative 6 is 6. And then I have just this play on negative 6. Which one's greater? The absolute value of negative 6 is greater. And finally, here I have 2.2 and then 22 over 10. If I change this fraction into a decimal by dividing 22 by 10, I will actually end up with the number 2.2. So 2.2 and 2.2 are both equal. So these are my answers. Now let's flip to the back of the notes and continue. When you're asked to order rational numbers, you have 2 steps that you need to adhere by. Change any numbers that are fractions to decimals, and then you can put them in order using the number line. Alright? We're going to start off with the first problem that we see, which is to put the following numbers in order from least to greatest. So in order to do that, I'm going to go problem number by number to see whether or not I need to change them in a way that's going to let me be able to number them and put them on the number line. So first off, I have negative 3. I already see negative 3 here, so I'm going to plot that here and write negative 3. Okay? I know that's where that falls. Then I have 2.2, positive 2.2. Alright? So if I find 2 on the number line, and I remember that there are little notches in between this, and that the center notch must be 2.5, then I know that maybe about here is 2.2. So I'm going to plot my point, and I'm going to write 2.2. Okay? So I got that done, I got that done. Now I have 1/8. Now, it's a fraction, so that means I need to do what? Change it to a decimal. So I'm going to come over to the side and I'm going to divide it out. 1 divided by 8. Of course, 8 can't go into 1. So I'm going to put a decimal point and a 0. 8 can go into 10 one time, which is going to leave me with a remainder of 2. If I bring that down, 8 can go into 20 2 times, and that's going to leave me with a remainder of 4. 8 can go into 40 5 times, and that's going to zero me out. Okay, so that means that 1/8 is the same thing as 0.125. Now, where is that on my number line? 0 point lets me know that we haven't even gone past 1. So that means this number is somewhere in between 0 and 1. 0.125. So if I know that half, 0.5, is like right here, and I'm talking about 0.125, that must mean I'm like super close to 0. So I'm going to plot my point. I'm going to draw up. I'm going to put 0.125 in parentheses. Really what I'm talking about is 1/8. Okay. Next, I have the absolute value of -6. I'm going to come over to the side and figure out what that is. The absolute value of -6 is 6. So I'm going to find 6, plot it. There we go. And last but not least, I have 1/5. Okay. Now, I am going to do the same thing. I'm going to change this into a fraction by coming over to the side. 1 divided by 5. 5 can't go into 1. So I'm going to put my decimal point in my 0, but 5 can go into 10 2 times, which is going to zero me out, meaning that 1/5 is the same thing as 0.2. Now, 0.2, if this is 0.1, then that means that 0.2 must be like right beside it. So I'm going to draw that up. I'm going to put my 1/5. Now that I've plotted everything on my number line, I can write them in order, because least is going to be on that side, going to greatest. As we go from left to right, we're going to get greater. So my final order should be -3, 1/8, 1/5, 2.2, and absolute value of -6. And as I write my final order, I'm going to keep the exact same numbers as I had up here. Okay? What I want you to do now is pause the video. I want you and a partner to work on this final problem. When you are finished, I want you to get your work checked by me, and then you can move on to the next IXL activity. Thanks. Have a great one.